Hi, this is Jiahao and Dimutu. Our project is about analyze and prediction of bank customer turnovers. Today we will align our presentation to introduction, data preparation, pre-processing, classification models, and classification with the PGA, performance measure, and finally the conclusion. Well, this project is about analyzing a bank turnover dataset. Here, this dataset provides information on various customers who maintain the bank accounts in a certain bank. The objective of this work is to build and evaluate best fitting predictive models which can determine whether customers will leave the bank in next 6 months or not. The primary goal of this project is to build a model so that is capable of detecting potential customers who might leave the bank. So this gives an overview of the data. Here we have a categorical and continuous and discrete variables. Here the final one is the target variable. Now this presents the basic statistical summary of numeric data. Here we calculate normal, standard deviation, mean, and standard percentiles. Obviously, when we look at the numeric data, we can find outliers. These box plots are obtained to recognize outliers. So these outliers can be eliminated in the data pre-processing stage. Now, the categorical data is to recognize this influence of parameters like gender, geographical location, credit card use, and the active status in the bank on the outcome variable. This provides a sort of visualization over the influence of outcome variable. Under the data pre-processing, first we converted these categorical attributes into dummy variables in order to obtain a standard spreadsheet format. Now here we used standard normalizer instead of min-max normalizer to normalize the data. In that way we can eliminate the outliers. Next, this data frame is divided into two sets for the model training and testing. Here when we look at this outcome variable, we can recognize that this variable is unbalanced. So therefore we oversamples this data set in order to obtain a good balanced data frame.
After we have a more balanced training data set, now we want to use the data set for building classification models that actually is capable of detecting positive cases, which means potential customers who want to leave the bank. In our project, the primary performance measures we used is the precision for positive cases, because we think it is more valuable for a bank to know about the customers who want to leave the bank rather than stay in the bank, given most the customers, around 80%, want to stay in the bank. And the secondary performance measures we also consider is the recall sensitivity, because we want to exhaust as many leaving customers as possible for our prediction model. The reason why we don't use the accuracy value for performance measures is because we think, because in reality 80% of customers are going to stay. If we just predict negative for each and every single case, we'll still end up with around 80% accuracy, but that doesn't reflect actual values. And then we try several models for our data set. We tried decision tree, KNN, Gaussian naive Bayes, and the ADA boost. For each and every single one of them, we get the key performance measures, and then we build the confusion matrix, as you can see from the images. Also, as a comparison, we also try reduce the data set from 10 parameters down to 5 parameters using principal component analysis. The way we choose 5 components is because the 5 components already capture 92% of the variance in the data set, and we deem that's a good enough estimate. And we tried the same kind of models for this reduced data set, and we record the stats. So after we have all the stats, and as we see, the primary measure we use is a precision for positive cases. So as you can see, the decision tree and ADA boost has the best precisions in that regard. However, since their precision are similar, then we move on to the secondary measurement, which is the sensitivity recall. For in this regard, ADA boost has much higher recall than the decision tree. So we deem the ADA boost is the best model for our data set. Thank you.